Hi, I'm just going to get started now. Anyway, so hello, welcome. My name is Danni Youziel, and hopefully you are here for this talk called Make It Make Sense. So, this talk is basically all about my pet projects, the different things I learned from doing those pet projects, and just a kind of overview of where you can go with your pet projects. Because for me, I had a slightly unconventional route into software development, and these projects really helped me in terms of just learning basic stuff as well as confidence. So there's been several apps that I've done. There was a music app that I created after seeing a Google Doodle, and that taught me a lot about audio and the web. There was a financial web scraper that I made for my cousin that introduced me to the beauty of Python and data frames, and there's been a whole lot in between. But like I said at the start, the focus of today is how some of these projects I've worked on have helped me get a wider picture of software development. So, if you, oh yeah, by the way, so my unconventional route was my first love is physics. So I ended up doing, no, sorry, my first love is music. No one's first love is physics. My first love is music, and that's how I ended up doing physics at uni. And then I got obsessed with time, so I ended up doing some research into quantum physics. Then I got a life and became a teacher. And then I decided I really don't like teenagers. So I saw the Google Doodle, decided to make one, did, and became a software developer. At the moment, I have issues with people in product, so we will see how far this career goes. But moving on. So let's break down what we're actually going to talk about, or what I'm going to talk about today. So letting go is good. I know some people may be a bit control freaky and stuff, but letting go is good, especially in software, because you cannot be everywhere. And there is so much going on and so much different things to do that sometimes just delegate. Use what somebody else has created before. I love using APIs. But you have to be cautious. But you have to be even more cautious because it's no longer a case of doing unit tests to test the functionality. There's so much more going on in terms of security, performance, and stuff like that. It can be better to get those things in earlier. Then I will talk about building big because there's a lot of data right now, and everything's about big data, big everything, and storage. And sometimes when you're trying to build big, the simplest solutions or answers are usually the best. And finally, I'm going to talk about trying things. We have online quantum computers now, and we've got chat GPT and stuff like that. And AI. And I, side note, do love the way a certain CEO said that we should not be using AI, despite the fact his company is actually still doing research into it. I mean, leading by example was never his forte, but I don't want to get sued. So, letting go. So, I spoke about APIs. Everyone's probably used some sort of API, and the API they usually give you to work with in the beginning when you're starting out is something along the lines of a weather app that uses a weather API. And what you do with it is going to be dependent on your requirements. So let's just say in the beginning, you just need to get back a 10-day weather forecast. You're just going to use the most simplest APIs. And I just kind of included this because I really like it. It's not really necessary, but hey. So APIs are like ordering food. You can have your favorite restaurant, or you can just order it through an app. And that app kind of acts like how you might use an API, because you can pick certain things or pick certain commands, and rather than actually having to, like, I don't know, go and fish and get the sushi and make it yourself, by picking certain instructions, you have told the restaurant how to make it, or they'll make it to a certain standard. And as long as everything goes well with your request, you will get back a delivery. And if it doesn't go well with your request, you can, or I will write a very strongly worded review. And we'll just test that, right, with as normal. We will have, or I would write unit tests to say, what happens when things go well and what happens when things don't go well, the happy path and the unhappy path. If everything goes well, use the information, go ahead and do whatever the app needs to do. And if things don't go so well, make sure there's an alternative path for the app to go down. And I guess that's fine when it's just bringing back a 10-day weather forecast. But I then extended that app. I wanted to use the weather API to be able to create a cultivation calendar based on historic weather data. That needed a different API, but that's going to bring its own issues. And I'm also going to need to do a different sort of testing. Because at the moment, all I'm doing is I'm testing the functionality. But what about the performance? And I'm talking specifically about the performance of my API that I'm going to use in terms of load, in terms of stress, and in terms of all those other kind of cross-functional, non-functional things that they talk about now that used to happen way further down along the software development lifecycle, but are getting more important as everyone talks about shifting left. So instead of just writing tests as a developer to look at the logic and make sure that works, I can also write tests to look at the performance, for example. So I can write a test that says, in a given amount of time, I want to make sure this call is executed correctly. And I can write a pretty basic one like that. Or I can go further and maybe let go a bit more and use a couple of plugins, for example. And one of the tools I used that I learned about, which was great, was something called K6. And you can more or less just write that into any app you're using when you want to test either a database query, call in another service if you're working with microservices, or also API load testing. And that one will give you thousands of virtual users. It can also stage those users, and then it gives you back a lot more information about the performance in terms of what percentage of requests came back within your specific time, what percentage didn't. And based on your requirements, or maybe your product managers or whatever, their requirements, that might be okay. It might be okay to say, I don't know, 90% of the requests were executed in the correct time or not. And I found that invaluable because not only did it help me when, I don't know, people further up the software development lifecycle will come back complaining about A, B, and C, but it also meant that I got a much better and much faster understanding of not only how my calls were working, but how my app as a whole would work. So, test with caution, but also test the wider picture. Next, there was building big and thinking small. So, I don't know if any of you know about this building in Taipei. It's called the Taipei 101 building. And it used to actually be one of the world's tallest buildings. And it's also in one of the world's most earthquake-prone regions. The reason that building is still standing is because it basically has a massive pendulum running down the center of it. That pendulum may look like some sort of architectural flair, but it's actually a massive shock absorber. So you've got this massive, massive building in this kind of technically earthquake dangerous place, standing due to a ball on the end of a string. And I kind of think about that and laugh a lot whenever I think of the first solution I came up with to this next one. And this is something you may or may not have come across before. But think about a PIN generator. So typical thing, everyone has their bank cards, and every now and again, you do actually have to enter your PIN in at the checkout. So how would you, or how did I go about first thinking of how to make a pin generator? Standard requirements, it's 4 digits. Let's say 0 to 9. The pin cannot begin with 0, and you cannot have any repeated pins generated. So first solution or first example would be something along the lines of, so I'll use a random number generator. I will store all the pins that have been generated. Every time I want to create a new pin, I will check against the list of pins that I've already got and also some validity criteria. There's a problem with that because when you're storing, 4-digit, all the combinations or most of the combinations for 4 digits, that's a lot. Let's say you want to ramp it up and store the digits for up to 6 digits. Or worse still, maybe 10. At that point, you're getting to a region of storing more than 1 million numbers. That's not great, and that's not scalable. But do I or did I actually really need to store all of the numbers? Or did I just need to keep track of which numbers were created so that I didn't repeat any? It's the latter one. So the thing is, the numbers don't need to be generated. The numbers just need to look, or the next pin just needs to look random compared to the previous one. So the random generator or random number generator isn't actually really necessary. What I need instead is this. This looks kind of ugly, but I'll explain it in terms of roulette. So if you imagine a roulette table, the ball goes round and it lands in a slot. And each of these slots are equal in length, and they've got probably equal probability. And this is something the casino and the customers rely on, every time the ball lands, it needs to land in a seemingly random place. How is that possible? Well, the thing is, where that ball will land will be dependent on everything to its initial speed, to the circumference of the wheel that goes around. And a slight change in any of those can result in a more random final position. That's basically what this equation does in terms of that list of possible pin numbers. It cycles through that list, and dependent on the numbers A, C, and M, it will go through them. The next number or the next pin will be a certain distance in that list away from the previous one. And as long as those numbers are chosen correctly, the A, the C, and the M, it will have a long enough period so that the numbers are not repeated. And all of that means all I need to do is store the state of the equation rather than that entire list of generated pins. So that does have its own issues, because if somebody manages to hack your system, I did not try and hack my own system, then you will have issues because they will be able to know which pins have been generated. But for a personal project, I think that's kind of fine. Finally and quickly, I would say try things. Try as many things as possible and literally use every 3-year membership you can from anything from Azure to AWS. But I would also say think about how you use it and what you actually use it for. So there was a period of time when I was actually slightly obsessed with facial recognition. And so I decided to use a couple of online tools to make a facial recognition application. I made a gender-based facial recognition application, which now is the most ridiculous thing I have ever done and ever created, because I would never know why anyone would need such an app. But then it was kind of fun because I got to learn a bit of machine learning. But I guess going forward, and if I ever did actually do anything big scale and serious with AI or machine learning again, maybe I would think a bit more about the consequences of what I build. So that is a really quick overview of my pet projects and what I have learned from them. I hope you enjoyed that, and There's 1 minute for any questions. Thank you.